So this is an important concept. Here's another example problem. We have 20 milliliters of sulfuric acid titrated with 21.08 milliliters of a known molarity potassium hydroxide. We want to figure out molarity of sulfuric acid. So again, write out the definition that you're looking for. The molarity is moles of sulfuric acid divided by liters of sulfuric acid solution. There's always two parts to a molarity, and you always have to be given one in the problem, and you have to solve for the other. The information you know about the sulfuric acid is that it's 20 milliliters. 20 milliliters we can turn into liters. There are 1,000 milliliters in a liter, so again, milliliters to liter conversion, you move the decimal over to the left 3 places, and you're going to get 0.020 liters of solution. So this is the denominator. The second part we want is the numerator. We want to figure out how many moles of sulfuric acid, and you always set it equal to the volume of the other chemical in the titration, 21.08 milliliters of potassium hydroxide. Eventually what we need is the balanced chemical equation. Because that is part of our conversion factor. So before we keep going with that conversion, let's figure out the balanced chemical equation. An acid and a base like this, remember, you can use the double displacement method that you learned earlier to figure out the products. The positive pairs up with the negative, positive pairs up with the negative. So on the product side, remember, subscripts do not get carried along unless they are part of a polyatomic. So for example, this 2 does not get carried along when I paired up the hydrogen with the hydroxide. What I'm pairing up with is a hydrogen with a positive 1, hydroxide with a negative 1. I have to do the little crisscross technique to figure out the product, HOH, which you can write as H2O. One product we make is water. The other product is we're pairing up the positive potassium with the negative sulfate. Potassium is a group 1 metal. It always makes a positive 1 cation. Sulfate is a polyatomic that you know. Sulfate has a negative 2 charge. So when I do this crisscross, positive 1 and negative 2, I'm going to get the formula. Potassium sulfate is K2SO4. Those are the correct products, but the reaction is not balanced. In order to balance this, I need to put a factor, a coefficient of 2 in front of the potassium hydroxide, and also a factor of 2 in front of the HOH or in front of the water. So balancing this reaction properly gives me the correct ratio here. In this case, it's a 1 to 2 mole to mole ratio. So I'm going to use that as one of the conversion factors. I have milliliters of potassium hydroxide. I want to turn those milliliters into liters. 1,000 milliliters of potassium hydroxide is 1 liter of potassium hydroxide. And 1 liter of potassium hydroxide has a known concentration. 0.420 molarity means 0.420 moles of potassium hydroxide in that liter. Now I can turn moles of potassium hydroxide into moles of sulfuric acid using the balanced equation. And we'll finish this one up on the next video.